Hello and welcome to your next video. We're going to be moving on now and showing how to show that triangles are congruent by limited amount of information. The nice thing about this is that in the last lesson we had to show that all the angles and all the sides were going to be congruent, but now we don't have to show that. So there's going to be a certain amount of information that we get to show, and that was going to be enough. So here's a scenario I want you to think about. Okay, a building contractor has just assembled two massive triangular trusses that will support the roof of a recreation hall. Before the crane hoists them into place, the contractor wants to verify that the two triangular trusses are identical. According to the definition of congruent polygons, if the three sides and three angles of one triangle are congruent to three sides and three angles of another, then the two triangles are congruent. Does that mean the contractor must measure and compare all 6 parts of both triangles? And so as mathematicians, we are always nice and lazy. We would prefer not to show every single thing. And so what we have done is created a couple of theorems to show enough information that will show that the two triangles are going to be congruent. So what that means is we don't have to show every single side are the same and every single angle are the same. So the very first one we have is called the side-side-side congruence postulate. And we abbreviate that using SSS. And what this says is that if three sides of one triangle are congruent to three sides of a second triangle, then those two triangles are congruent. So as you can see in here, I don't need to look at anything that deals with angle measures. All I'm focusing in on are the side lengths of each side. So what we want to do is take a look. If the first side, so in this case AB is congruent to RS, is congruent, and the second side, or in this case BC and ST, are congruent, and the third side, AC and RT, are congruent, then we can say that triangle ABC is congruent to triangle RST. Now you have to make sure you're maintaining the correct congruent statement that we have here. We want to make sure that AB and RS are in the same spot, and you can see that they are. Same thing with BC and ST and AC and RT. Okay, so that's the side-side-side congruence postulate. Again, we use SSS to abbreviate that, and so when we start using them in proofs, we're going to do that exact same idea. So what we want to do is take a look at these and determine whether or not the congruent statements are true, and then we want to explain our reasoning. I would advise to hit the pause button, go ahead and give this a try on your own, and then I'll explain how to do it. Okay, so let's take a look at the first one on the left there. So if I take a look at just the triangles themselves, I can see by side that they are congruent because we have this side is congruent to this side is congruent to this side, and this side is congruent to that side. So that way we do know that they are that way. But now we want to make sure is that our congruent statement is accurate. So the first thing here says DF is congruent to HJ. So you want to go back and just verify, is DF congruent to HJ? And you can see that yes, those guys are in corresponding positions, DF and HJ. So let's just check one more. So we have FG and JK. So I have FG and JK. Those guys are in the correct spot. So we can say yes. Since all three of those sides are congruent to each other, we can say that those two triangles are congruent by side. Okay? All right, moving on to the one in the middle there. So let's take a look. We're looking at the top triangle versus the bottom triangle, and there's one thing that stands out to me, and that's this guy right here. So they're sharing this side right here, so we know that those sides are going to be equal, and we see that this is 7 and this is 7, but the real key thing there are those two measurements right there, the 3 and the 4. So the answer to this would be no. Because one of the side lengths is not equal to the other length of the side, therefore they are not going to be congruent. So last but not least, let's take a look at these last two triangles. If I take a look, I can see again that the two triangles are congruent by side. So what we want to do is now verify that the actual statement is correct. So the first statement says QP is congruent to RT. So when I go back here, I see QP and it's congruent to RT, and that is an inaccurate statement. So in this one, I'm actually going to say no. So while the two triangles above are congruent, the statement indicates that QP is congruent to RT, which is false, and instead, and I know it's really hard to read, it's probably got cut off, it say QPT is congruent to RST. Okay. Our last example here is just using a graph to do this exact same thing. So I'm identifying the two triangles, JKL and their vertices, and the triangle RST and their vertices. So I went through and I plotted those points on the graph. And so now from here, I want to verify, are these triangles actually the same length? And so what we can do is use the distance formula. When we have the horizontal or vertical lines, like the ones that are up and down this way and this way, we can just count and that's fine, but you could also use the distance formula. So for the first one, JK, which is the short length here, that's length 3, and this short length here, RS, is also 3, so we know that JK is congruent to RS. Moving on to the next set here, we're looking at JL, which is the up and down one, and the left to right one, RT there. Those are both length 6, so we know that they're congruent. And so then finally, for KL and TS, we're going to use the distance formula, and we can see that both of them get to be the square root of 45, or 6 point something, depending upon how you did that. And so because all three lengths are going to be the same, by side, 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 that's enough information. And so I can say that triangle JKL is congruent to triangle RST. And that's kind of the big idea behind side, side, side. All you need to do is in some way show that the triangles are congruent. And that's all for today. Nice short video. Let me know if you have any questions.